Exercise number 5. For this exercise, we will make use of the storage account that we previously created. So let's begin. We're going to create a new file. We're going to name it terraform.tf. Terraform backend. This is how we specify to use the backend we created previously. Azure RM. Resource group name. Equals exercise 04. The storage account name. Which is the same, exercise 04. Container name. Exercise 04 dash container. And the key for it is Terraform TF state. Okay, that's it for this file. So basically we're specifying where the backend is. It's going to be on the resource group name exercise 4. The storage account name is exercise 4 and the container is exercise 4 dash container. And it's going to contain the Terraform TF state file. So let's move to the next file, which it is our providers. So new file providers.tf, which is pretty standard, the same thing that we've been doing before, so nothing different. Probably new Terraform version, but that's about it. So require providers. Azure RM. Oops, underscore. Azure RM equals the source. HashiCorp. Azure RM. Basically, we're telling Terraform where to download the provider that is needed to talk to Azure API. That's all it is in here. And which version are we gonna use? We're going to use 2.91 or higher than that, newer version than that. And now to the mandatory section, which is the provider Azure RM. And the features. Yeah, that's it. That's it for this file. Now to the next one, which is our locals. Yeah, locals.tf. You can use locals for many things. I'm only using them for tags, but you can use it for many things. We might explore some uses later on this course. Required tags equals owner equals bar dot labels owner. This basically labels maps to Terraform TF bars, which is a dictionary. We can tell based on the way the data is getting retrieved using a key value pair. Subscription bar dot labels subscription market bar dot labels market and the resource group type. Again, this can be anything that you might want. I mean, I just made this up, but try to make use of it. Bar labels resource. Need to put some quotes in there. Resource group type. Closing that. Yeah, that's it for it. So, as I was saying before, try to make a better use of your tags, because it can help you identify resources, who is the owner of a particular resource, or the support team, stuff like that. So with that out of the way, we move to the next file. So the main.tf, I always name it that way, but it can be any name, to be honest. So in this one, I'm going to include the actual resource group. So sure rm resource underscore group, and the name, I just give it rg. Try to be a little bit more descriptive than me on this. And now we're gonna introduce our first concept. Well, the first one was actually the Terraform TF file. This would be the second one. So for each bar resource underscore information. So for each is very similar to count, that is the a tool that we've been using to create multiple resources on Terraform. It works similar, but this one relies more on mapping. Basically maps the key value pair, uses that, so it's a little bit more efficient than a count that relies like on a listing, goes by order. We're gonna talk about count, for each, for loops and stuff like that on the next video, because I think it's important to clarify those concepts, because you can use this to make your life easier on when creating a Terraform resources. And so the purpose in here, I'm going to create multiple resource groups and multiple virtual networks, multiple subnets, multiple instances, and I'm gonna use for each in order to create that. This is just an example. I don't personally recommend you create two resource groups at the same time, because the way Terraform operates, it will try to do them in parallel. So some resources might try to access information from another resource, and that other resource is not really created at that moment, so it might fail. So that's why I stay away from that. But I mean, for this exercise, just an example, you're gonna be extensive use of for each across this exercise. So let's continue. Name each that key. You're gonna see what the key and the values are for that. It's under the variable resource underscore information. And the location is going to be each that value. So it's basically retrieving information from a map on Terraform. Tags equals local required tags. Great. Now let's create the variables tf so we can go back to the for each, so we can have a visual representation of it. So new file variables.tf. We're gonna need also Terraform tf bars after this one. So let's create our first variable, resource information. Description. I'm just gonna type resource. If you use something like Terraform docs to create your documentation, it's very important that you use the description more properly, because basically you're creating your own documentation from there, so it helps when your description is really good. The type, well, we know that this is a map. Variable labels. This one is also map. Description. Labels. Type map. I think that's it for now. Okay, so let's move to Terraform tf bars. Terraform.tf bars. So resource resource information equals production yes US and development. This is gonna be the other one that we're gonna use in here, equals ES US2. That's it. Labels. Another dictionary owner equals myself. Oops. Subscription. DevOps. I mean, this is just an example. That's why I'm so relaxed on this. Market. US. And the last one, resource. Resource. Yes. Group type. application app. It's fine. Okay, so resource information, right? So let's go back to main. So for each on the variable resource information, so for each value in here, which is actually for each key value pair, we have two. Productions equals ES-US and development equals ES-US2. So for each one of them, you're gonna basically populate these results. The name is gonna be key, which is production, and the other one is going to be development. This is the key, and this is the other key. And the location is the value. So one is going to be ES-US and the other one ES-US2. And the tags, just regular tags. With that, we move to the next file, which is the network.df. So resource sure RM virtual network, and the name, I just name it bnet. Okay, next new concept. We're going to introduce depends on. Remember when I mentioned to you just a few moments ago that since we are introducing for each on the very top level for everything in here, for the resource group creation and stuff like that, so the way Terraform works, it tries to create as many resources as possible, so it works on parallel most of the time. It depends on you're gonna control that behavior, like don't start creating the Azure virtual network resource until the Azure RM resource group is ready. That's how we control that. Because without it, we're gonna get errors. I mean, I might leave one out so we can see the error. Yeah, I'm gonna choose like maybe the subnet piece. That would be ideal. So let's carry on. So it depends on, that controls the creation time. And now we do our for each, because we're gonna create more than one virtual network. And bar that resource information. So the rest is the same. Has a name, each that key. It's gonna have a location. It's basically the same thing. Each that value. Resource group name. Each that key. Normally over here we usually make a reference to the resource group resource, but since we already have that value, we already know what it is. I'm just telling Terraform what it is right there instead of navigating the whole Terraform resource block. Address space, yes. This is a list, and I'm gonna 10.0.0.0/8, which is excessive. This is way too freaking much. Way too much. Way too many IPs. But for an example, it's fine. So let's create our subnet. Resource Azure RM subnet. Great. Our depends on. We're going to include the resource group, but we're gonna omit the virtual network and see how it behaves. Well, it's gonna break most likely, and when it does, we just add the virtual network, because clearly you can see this is a list, so it takes multiple elements on it. So for each bar that resource information, and it's exactly like the URM subnet requires a name, each.key, resource group name, each.key. We already know what that is. Production or development, that's gonna be the names. Virtual network name, each.key. It's going to be production or development. Those are the names that we're using again. And address prefixes. Okay, we can use over here if statements, because we introduced those on the last video, I think. So just to review it again, so if each key equals production, then bar that subnet is going to be production. We need to close that. One more. Oh, of course, missing this one. Okay, now we're good. So if it is production, use the production subnets. If it is not, then use the subnet. I mean the development subnets. That's our for loop. I mean our if statement. If equals production, then use this. If it doesn't, then use this. Straightforward. And we are leaving the depends on the virtual network, so we can see it fail. So the next one is the public IP. Azure RM underscore public IP. I am missing something. This will be helpful. This will be helpful too. Public underscore IP. So it depends on the resource group being created, and we're gonna need more than one, of course. So for each bar that resource information name equals each that key. Resource group name, same as before, and the location, each that value. Allocation method, of course. For this example, because it's an example, nothing serious is being created in here, I'm going to specify dynamic. If you're creating something that is actually important, then probably static is a better option. Now we go to resource. We're gonna create the network interfaces that are going to be attached to the virtual instances. AzureM network interface. Okay, depends on, of course, we know what that is. AzureM resource group .rg. On our for each bar that resource information. Name equals same as usual. It's a little bit repetitive. Can then I that resource group name each that key location each that value. That's not right. Oh yeah, enable accelerated networking. This is true or false. Just to add a boolean value so you can see it. And it's complaining about something here. Each value. Nope, this is good. It's the way it's supposed to be. We need just the IP configuration section. So name equals each the key. This time I'm including side quotes because I'm gonna customize it a little bit. Each that key dash IP dash conf. Subnet ID. Equals AzureRM underscore subnet dot subnet and each dot key. That's how we call that one, that ID. Yeah, it's gonna come from this one. So it's gonna be production and development. Syntax here. What else do I need? Subnet ID. Oh, yeah. Private. Yeah, private. IP address allocation. Autocomplete. Dynamic. And we're gonna attach our public IP address in here as well. Public, IP underscore address ID. AzureRM underscore public underscore IP that public IP. Since we're creating multiple of these, that's why I need to specify each that key, every single of them. That ID. And it looks correct. We'll see if it passes validation. So that's it for this file. Let's move to the next one. Actually, we define a few. We need to declare a few variables like what is subnets. Yeah, we need to do that. So let's go back to variables. Variable subnets. Oh, misspell. Description. Yeah, subnets. Why not? Type. We know it's a map because the way the values were called in the actual module. And we have another one. Oh, accelerated network, the Boolean one. Variable acc_net. And the description. Accelerated network. Of course, quotes. The type is going to be Boolean. Terraform TF bars, we need to introduce those as well. So subnets, that's a dictionary. So the production subnet is going to have equals 10.0.0.0/24 255 IP addresses in there, and the development is going to have the same amount, 10.1.0/24. Yeah, it should be correct. On AC_net accelerated network, false. Okay, with that we move to the next file, which is security. Yeah, security.tf. So resource Azure network underscore security group NSG. Yeah, looks correct. Okay. It depends on, of course, and it's gonna depend. Everybody's gonna depend on source group for sure. Just this subnet has an additional dependency. Now we do the same thing that we've been doing so far for each. Source information, name, each that key. So gonna be production or development, resource group name, same thing, each that key, and the location, which is each that value. Great. I'm gonna include a security rule in here. It's telling me that it's gonna autocomplete. Let's give it a shot. It didn't do anything. Oh well, I tried. Let me do it my way, like that. So name equals, we're gonna create a custom name, ish.key, closing that, dash SSH. That's the only access that we're gonna probably need. Well, for this exercise, you might need to open different things. Priority. Okay, priority needs to be from 100 to 4096 if I'm not mistaken, so you cannot use 1 for sure, that will fail. I usually start with 1001 and go up from there. Direction, inbound, because it's gonna be us connecting to the machines. Access, we going to allow it. Protocol, TCP, source port range. Well, ours star because it's gonna be ephemeral. Destination port range, destination port range, and it's gonna be 22. And source address prefix, it's going to be us, at least our public IP address data that, speaking of that, I need to include that file, data.http that IP address. That's why autocomplete is not helping me here. Address dot body. Yeah, it looks correct. So let's finish this one. Actually, let's include the file. I see it here, so copy, paste. Yep, that's it. Let's continue now. Now that that's done, we need one more thing. Destination address prefix. It's going to connect to all the VMs in there. Well, we are going to connect to all the VMs in there if we want to. That's it for the security rule. We need to associate it. So resource Azure RM underscore subnet underscore network underscore security. I would really appreciate if autocomplete triggers in here, but it's not doing it. Group association, or that's a really long name. I mean, it's descriptive though. I mean, you can tell what it does. Sec underscore group. So for each, yeah, there is no depends on in here. I mean, we can add one, but I don't think we need here. Yeah, let's not include. Let's see if it fails here as well. If it fails, then we gonna add, and it depends on whatever resource is failing. If it does, so bar that resource information subnet ID equals Azure RM underscore subnet. And since we're creating multiple of those, is that key that ID and the network security ID Azure RM underscore network security group NSG. We have multiple of these as well. Is that key, and we need to, I mean, we are creating two separate resource groups, so each one of them needs to have their own dedicated network security group. And the key, oh yeah, that ID. That's it. That's it for this. What else do we need? The variables that I need to work with? No. Okay, perfect. Let's move to the next file, which is availability set. So availability underscore sets.tf. Just to add them, I mean, for this exercise, they do not make any sense whatsoever because I'm only creating one VM per resource group, so there is nothing in there to be added. Basically, what it does, the availability set, is creates the equivalent of having a disaster recovery location. So you have your primary location and you have your disaster recovery location. Something bad happens on primary, then you fail over your application to the disaster recovery. So it's like adding an extra redundancy. So let's create that resource AzureRM it's gonna make me type ability underscore set availability underscore set. And of course depends on the same usual suspect, the resource group. We go for each, same thing that we've been doing so far, resource group information, the name we already know, it's going to be each.key. We can do a custom just to play with it. So $squiggly bracket each.key, close the squiggly bracket, dash availability. Hopefully I didn't misspell that. Well, the location each.value. Resource group name each.key. Manage true. Well, we could use variables in here and use a boolean, but not right now. Tags local that require tags, and that's it for this guy. We're going to the next file, and I think will be the last one. Is it? Well, we'll see. New file, instances.tf. Well, everything is an instance, even the virtual network is a virtual instance kind of deal. Resource AzureRM underscore Linux underscore virtual machine. Just name it VM in here. You can add depends on this one, but I normally seen the virtual machines always get created at the very last, so I don't think we need that. We need to add a depends on this one. I mean, if it fails and the error is telling us that it's depending on something, then we can add it, but I don't think we're gonna need it. Pretty sure. Name equals each.key. Oops, key. location is that value, resource group name is that key, network interface IDs. Since it can have multiple of those, but in our example we are just using one per virtual machine, just one network interface, that's it. Azure RM underscore network interface, yes, is that key, that ID, yeah, that's it. Size, we can play with the sizing here with just for practice, if statements. So bar dot labels owner, why that looks different? That is weird. We'll find out if it is an error. So if the owner equals Bob, now we change color, then bar dot bm size, which we haven't created yet, we're gonna create one, production, we're gonna have a special size, bm size for production, and another one for development. So if the owner equals Bob, then we're gonna use production. If it is not Bob, then we're gonna use the development one, bar dot bm size development. Admin username, no admin password. We're gonna use SSH keys because security is important. So bar username. Nope, I don't have a variable called like that. Well, I could, but no. Keep in mind that we are only restricting access by firewall, so it's always important to check back with your InfoSec team if you happen to have one. Hopefully you do, to see what else you can add to secure your resources, your virtual resources, because this firewall is not enough to keep your system secure. You need more. It's not bad, firewall is part of security, but you need always to add more, to have more security in place. That's not a bad thing, always is a good thing to keep that in mind. So with that, let's continue. Disable password authentication, absolutely true. What else? Tags, of course. Local required tags. Before we go any further, let's add a few variables. Let's declare them. So variable, of course, BM size, yeah, remember that one. Description, sizes is fine for me for this exercise. The type is going to be a map, which is like a dictionary in Python. Username is the other one. So variable, username, description, user, type is going to be a list. For that one I'm going to use a list. Yeah. Now df bars. VM size equals not quite there. Dictionary. So production. Standard d1 underscore beer version 2. I'm not even sure what that size is. I'll just pick a random one. And development. Standard d2 version 2. Okay. And the username, yes, which is a list. Username equals brackets for list. Sure user. And the other one, just a made up name, just for the example. Pancho Villa. Yeah, that's it. So we can go back to our instances. After required tags, we need the OS disk, if I'm not mistaken. OS disk. Name for the disk is that key. Caching is read write. Disk size on gigabytes. Bar that disk size. Storage account underscore type. Another variable. Bar that is storage type. Yes, since yeah, not missing anything. Doesn't look that way. So let's add the variables for those. So username, variable disk size. That was the first one. Disk size. Actually, like that. Description. Disk. Type equals number. Yep, it's a number. We can use a default value. Basically, you can include it in every single variable, just defaults. Gonna use 30 because it's the smallest size that Terraform, Azure RM will create disks. That's the smallest one. So you're gonna use it as default. What else do we have? Oh, storage account type. Yeah, that one. Description equals account. It's fine. This one is going to be string. Type string. Yeah, that's it. TF bars. Disk size is the first one. Yeah, one. It can be one. minimal is 30, so we're gonna give it 50. Storage. Why is not completing? Better go and check. Storage account type. Standard. Yeah, standard LRS. Why it didn't complete? Storage. Yep, looks correct. Well, let's carry on. That's it. Let's go back to instances. OS disk. Oh, yeah, the actual OS. Source image reference. Publisher. Bar dot publisher. Offer. Bar dot offer. SKU. Bar dot SKU. Version. Bar dot OS. Version. Okay, let's go and add these 4 variables before we forget. So variable publisher was the first one. Yeah. Oops, not public IP. Publisher. Description. Publisher, I guess. I'm gonna use canonical, so it's fine. Type string. Variable offer. Description equals offer. Type equals string. SKU. Variable SKU. Description SKU. And the type string as well. And the last one. OS version. Description OS type equals string. I think we're done. See, yeah, that's it for this. Now we need how to access it, of course. So admin SSH key, username going to be bar dot username. First element, the public key. SSH ID RSA that pub. Okay, we are pretty close. Oh, yeah, the outputs. That would be nice to have outputs. The only thing is I'm not sure how reliable that one is going to be because the way we are creating the resources with for each and having so many dependencies. But let's create an outputs file. We haven't done one in a while, so output.tf. Public IP address. Since we have multiple of them, there are several ways we can access. Well, yeah, several ways we can access. We can just get all the information from the public IP address Terraform module, but in reality, we are only interested on the public IP addresses themselves, not the rest of the information. So for that, we need to specify the actual resource group name in order to retrieve that information from that module. And output doesn't support count and doesn't support for each. So we are going to use a classic old school for loop. Well, old school for other languages like Bash, Python, Perl, all of them have it. IP_address in. So let me type it and then I'm gonna basically tell you what it's doing. Azure RM. What is public IP? Yeah, that's the one I want. Public IP that public_IP. That's what I define that. Then we do name IP_address. This can be anything. Basically, I'm using these two in here. That's what I'm doing. So you can make them be anything else. But in reality, I'm pretty much telling I want the IP, the key from the IP address. I mean, not the key, the value from the IP address key. That's what I'm doing. So first, let's look at the public IP module on network. Right here. So it's everything that gets produced by this module, we're gonna get it from the output. Well, not right now. Well, yeah, we will do it. We will get it. And we are basically going to walk the entire results, go for what it for loop does. Basically, goes for each single object on the output from a public IP address, and we will retrieve something from it. So it's going to do, let's go to network again. So it's going to do for name. So it's going to go name, resource group name, location, method, the actual IP address, and a couple more elements that get produced by it. So it's going to walk each single one of them, and we're specifying, yeah, but we want the IP address of it. Just that's what a for loop will do. And with that, and this just basically telling that give me the dictionary, the map of that. When we use this syntax, is I want the result as a map, as a dictionary. So with that, let me throw a save all, and let's see how it goes. Terraform init, that's the first one. initializing backend, so it's going to connect to exercise 4 storage account. Perfect. So it's creating the actual Terraform TFT file. We won't see this guy on exercise 5 because it's remote. So everything good. Let's do Terraform validate and see how many mistakes we have. We have a lot. Of course, typo. Yeah, it's gonna be twice because we are creating 2 of them. Missing argument. Well, let's fix this one. Private. That's autocomplete. Yeah. So network. Let's look at all the bad stuff on network. Private. Okay, this is one. And this is the other one. That was me not coordinating with autocomplete. So let's save it. Let's do a validate again. Let's see what error. Interface IDs, H key. Oh, of course, we are missing stuff. We are missing this piece in here. So let's go on instances. That network underscore interface, and now it works. Well, let me save it. See more errors. Oh, no more errors. Okay. Now we move on to the next set of errors. So we're gonna save it, create a plan and save it. TF plan. We won't see the subnet dependency here. Look at that, I completely forgot to declare the variables for offer and probably the last 4. So let's cancel that. And let's add the definition of, actually I did. Oh, okay. TF bars. That's what I was missing. It's missing. So storage account type, a publisher, yeah. Publisher, canonical, if I'm not mistaken. Offer Ubuntu server. SKU 18, probably should switch for 20. I gotta check if it is available on the region. Probably it is. LTS OS version, yes, the latest and greatest. Save it. Let's throw another validate. I don't think I have more errors, but we never know. Yep, validate. Oh, let's make it pretty. Terraform FNT. Okay, all aligned, perfect. And it depends, stay the way it is. Okay, that's fine. Now our Terraform TF plan. So let's move on to the next set of errors. Time sleep wait. Don't recall adding that in there. It's probably from the first run that I did. Okay, there you go. So going to create, destroy, yeah, it's from the previous run that I was testing a few things here and there. It's gonna be destroyed. It's gonna add that. It's gonna add a lot of stuff. Okay, let's do Terraform. Apply TF plan. Let's see if we should have an error for the subnets. Come on. Destroying that. We should have an error pretty soon, hopefully. Subnets. Oh, come on, I really need that error. Excellent. The resource production was not found. So the subnet, yes, is complaining that the virtual network production is not there. Cool, and we should have the same for development as well. Yeah, perfect. Cool, so that's explained. We just added, so we add a command here, probably on there, just to keep it organized. Sure rm network virtual network at the very end. Now we save all. Terraform validate, just in case I introduce a type or something. And I did. Of course I did. It needs this. Never fail to disappoint. Terraform validate. Okay, valid. Our plan. Acquiring state lock. Yeah. That's the way to prevent, if multiple people working on the same file, is a way to prevent other person editing the same file at the same time. That's how they control that. So Terraform apply TF plan. And now everything should work. When you destroy this, try not to use Terraform destroy, because the same issue, why the way Terraform behaves, it will try to be efficient, and it might delete something in the wrong way. So when you go and delete these resources, you do it through the portal. So delete resource group and the portal. Each single one of them is just two of them. One is production and the other one is called development. Well, if you did exactly as the exercise, you can name it whatever you want, but just make sure that you do it through the UI, the web graphical interface, instead of doing it through Terraform. Or you can do it through the ACCLI as well, one by one. Yeah, if you do it with Terraform destroy, we'll try to do it in an efficient manner and might delete the resource in an out of order way, and it will make it more difficult for you to actually delete it. You have to wait a little bit for the API to actually sort out the little mess that it gets created with this. So we don't have the output. Yeah. So if I have Terraform output, it completed everything successfully, but it's not giving me what I want at the end, which is the public IP addresses. Suspect if I run the plan -out -tf plan, it will know about it. Pretty sure it will. Acquiring state lock, just making sure that I'm not creating conflicts. Well, it's just me working on this file, so it shouldn't be a big deal. There you go. See, the IPs is just the way they get created, I guess. It's an order thing, but we can just apply it, and this time we're gonna be really quick. Apply TF plan, just to get the output. That's all it is. So we can get the actual output. There you go. That's it. as Terraform output. Yeah, and we can SSH assure user at 40.117.134.77. There you go. Let's look at the disk. 50 gig. Yep, that's the one we wanted. And we can probably SSH into the other one. So Terraform output. .114.198.51. Yep, it's gonna take a little bit, but that's fine. So I'm gonna add in the notes. There is another video on YouTube from another person that he goes. He's explaining a little bit of a for loop, for each, and count as well. I'm gonna include it on the notes, so you can in the description. Actually, I'm gonna post the link in there so you can go and check it out. I'm gonna make one about them later. It's gonna be the next one, so we can cover those elements. But in the meantime, you can have that as a reference and just look what it is and how they work. Yeah, and with that, we conclude this. Yep, and happy terraforming.